Alrighty, ladies and gentlemen, this is our 747 test, and I'm going to do a little YouTube study guide for you. So, first problem tells you that the sine of x is negative 1/4, and then you're in quadrant 4. So, I'm going to draw a little helper triangle here in quadrant 4. So, if they tell me that the sine of x is negative 1/4, then I'll label that 1 and that 4 because this is opposite over hypotenuse, and in the fourth quadrant, y is negative. We need to know what the x value is for this, so I'm going to do 4 squared equals 16 minus 1 is 15, so that means that this is the square root of 15. Since you're in the fourth quadrant, x is positive. Now that I have my triangle filled in, I can start to actually evaluate these things. The trick to this, though, is that when you're asked to find the cosine of 2x, the sine of 2x, and the tangent of 2x, you need to make sure that you remember that that is an identity. So let's start off with the cosine. The cosine of 2x is 2 times cosine squared x minus 1. There's actually 3 different identities you can use. I just picked this one because that's the one I had memorized. The reason we need that is because now I need to figure out 2 times the cosine. So the cosine is radical 15 over 4 because that's adjacent over hypotenuse, and that's going to get squared, minus 1. That's 4. Then when I square that, radical 15 squared is 15, and 4 squared is 16. So 2 times 15 sixteenths minus 1. 2 times 15 is 30. And just while I'm at it, I'll get a common denominator. 1 is 16 sixteenths. So the cosine of 2x would be 30 minus 16, which is 14 over 16, which will reduce to 7/8. So the cosine of 2x is 7 over 8. I need to do the same thing with sine, so let's do the same thing with sine. The sine of 2x is 2 times the sine of x times the cosine of x. Also, an identity that you should know, you're going to get the formulas on the test, but you need to recognize that, hey, those are things that you need to be able to evaluate. Very similar, 2 times the sine. They actually gave you the sine, but again, it's opposite over hypotenuse, times the cosine, adjacent over hypotenuse, radical 15 over 4. And when you multiply the fractions, you multiply across. 2 times 1 times radical 15 is 2 radical 15. It's negative, so I'll just make that a negative. Over 4 times 4 is 16. So, similarly, the sine of 2x is negative 2 radical 15 over 16. Now, the tangent of 2x, you can do this a couple different ways. There is an identity for tangent of 2x, but since I'm not very good at memorizing that stuff, what I'm going to do is I'm going to just recall that tangent of an angle is sine over cosine. So that means that tangent of 2 of those angles would be the sine of 2 of those angles over 2 of those angles. The reason that's so much easier is because I have sine and cosine right here. So negative 2 radical 15 over 16, that's the sine, divided by 7/8. It becomes a lot more straightforward here because it's a copy change flip problem. Negative 2 radical 15 over 16 times the reciprocal is 8 over 7. And when you simplify the numerator, negative 2 times 8 is negative 16 over 16, and you can hopefully see that those are going to cancel out. I forgot my 7 down there. That's 7 right there. So I end up with negative radical 15 over 7. So the tangent of 2x is negative radical 15 over 7. We're going to pretty much do the same thing for this problem, but we're in quadrant 2 this time, so I'll draw my little helper triangle. And in the second quadrant, I know that tangent is opposite over adjacent, so 4 over 3, and since the x is negative in the second quadrant, we'll put that there. This is a Pythagorean triple, 3, 4, 5, so that's 5. And I'm going to do the same thing I just did. So the cosine of 2x is 2 cosine squared x minus 1. 2 times the cosine is negative 3/5 squared minus 1. It's negative 3/5 because that's adjacent over hypotenuse. 2 times, when you square a negative, you get a positive, and 3 squared is 9, 5 squared is 25, minus 1. Multiply 2 times 9, 18/25 minus, this is 25/25, and you end up being able to say then that the cosine of 2x is 18 minus 25, or negative 7/25. There's cosine. We'll do the same thing for sine. Sine of 2x is 2 times the sine of x times the cosine of x. So 2 times the sine is positive 4/5, and the cosine is negative 3/5. So when I multiply across on the top, 2 times 4 is 8, 8 times 3 is 24. It's going to be negative because there's a negative in there. And 5 times 5 is 25. The sine of 2x is negative 24 over 25. Lastly, just how I did it before, I'm just going to take the sine over the cosine, so negative 24 25ths divided by negative 7 25ths, and this will get me the tangent. So the tangent is negative 24 over 25 times the reciprocal, 25 over negative 7. That's important you keep track of the signs. The negatives are going to cancel out. A negative divided by negative is positive. And here you can just cancel those out, and you end up with a positive 24 over 7. So the tangent of 2x is 24 over 7. Those are very similar problems, so you should treat them very similar. Alright, inverse functions. Some of these are going to be able to do in your head. Some of them are going to require a little bit of work. The first thing you should be able to tell me is that if you're dealing with an inverse cosine problem, the range of inverse cosine is restricted to the top half of the graph. So our answer is always going to be in the top. Even though cosine is negative in both the second and third quadrants, when you're doing inverse cosine, it always has to come from either the first or second quadrant. So when they tell me the inverse cosine of negative radical 3 over 2, I know I'm in the second quadrant because cosine is negative over here. Now, I actually know that cosine is negative radical 3 over 2. When cosine is alongside, that's a 30-degree reference angle. So if this is negative radical 3 over 2, what I'm asked to do is find the cosine of that, which is adjacent over hypotenuse. This is on the unit circle. So this is a pretty easy problem because the cosine of the inverse cosine, those are going to cancel each other out, and you end up with just negative radical 3 over 2 because cosine is adjacent over hypotenuse. This problem's kind of similar. You've got tangent of radical 3, but tangent is restricted to the right side of the graph. So when tangent's positive, you have the choice between the first or the third quadrant, but when you're doing the inverse tangent, you're always pulling from the first quadrant. Now, I just remember this, that radical 3, tangent is radical 3 when you have a 60-degree reference angle, and across from 60 is radical 3 over 2, and across from 30 is 1/2. So if you ask me what the cosine is on the unit circle, this would be 1/2, because cosine is the x value over 1. This one, I'm going to need to draw a little bit of a helper triangle. So just like we did before, I'm going to say, okay, cosine is positive up here somewhere. Cosine is positive in the first quadrant, and I'm going to draw a helper triangle that will say cosine is adjacent over hypotenuse. I'm not on the unit circle in this problem, so I need to do the Pythagorean theorem. 64 minus 9 is 55, and that is then the square root of 55 when you do Pythagorean theorem. Now they're asking me to find the sine of that. The sine is opposite over hypotenuse, so this would come out to radical 55 over 8. This guy is just sort of a one-step problem. You should have this memorized, and you should know that, again, tangent's on the right side, so an inverse tangent of negative radical 3 over 3, that's a 30-degree reference angle, and since you are below the x-axis, then we're talking about, let me sketch it here, if you're below the x-axis, 30 degrees, I'm going to guess that our answer should probably be in radians here, so even though that's a 30-degree reference angle, we're going to say this is negative pi over 6. Now, that's important because it's not, in degrees, 330 degrees. It's not 11 pi over 6 in radians. It has to be between negative pi over 2 and positive pi over 2. When you're dealing with inverse tangent, your answer is always going to come from negative 90 degrees to positive 90 degrees. Let's just try it on the old calculator and see. I'll do it in degrees so we can be for sure. So if I do the inverse tangent, we should get negative 30 degrees. Negative radical 3 divided by 3. This is, negative 30. So because your answer is not the same as 330, your answer has to come between negative 90 and positive 90, or negative pi over 2 and pi over 2. Inverse sine of radical 3 over 2. Sine is radical 3 over 2 when you have a 60-degree reference angle. So this is radical 3 over 2. This is 1/2. That's a 60-degree reference angle. If I'm asked for the cosine of that, the cosine would be 1/2. And I need another helper triangle for this, 8/9. So I'm going to say the inverse sine is going to be the first quadrant. That's not horizontal. Draw a helper triangle, and they're telling me that opposite over hypotenuse is 8/9. 81 minus 64 is 17, so this is radical 17. And now I'm going to do the cotangent. Cotangent is adjacent over opposite, so this would be radical 17 over h. So first page down, looking good. We're going fast. You guys can handle it. You hit pause if you want. Alright, number 4 says express theta as a function of height. So my answer, if it says theta as a function of height, it needs to be theta, and the only variable I'm allowed to have on this side is an h somewhere. Now, what might help is to think about what trig function will tie theta, h, and 720 together. So you might start off by saying the sine of theta is h over 720. Well, that's great, but that doesn't have theta isolated. If I was going to isolate theta, I would need to essentially flip the x and the y, so the theta is on this side. Hey, lucky for us, we know that when you flip x and y, you're taking the inverse function. So this is the inverse sign of h over 720. You flip x and y, you change this to the inverse sign, and now you've got theta in terms of h. Now, if I actually give you a height, if this is now 640, you're going to say, okay, I want the inverse sign of 640 divided by 720. And I can get my calculator back out and say inverse sign of, that's regular sign. Inverse sign of 640 divided by 720. And I get 62.7 degrees. So 62.7 degrees. So this angle right here is 62.7 degrees. Number 5, we're actually going to start solving now, and you need to pay very close attention to the directions here. This says between the interval 0 to 2 pi, which means my answer is only going to be in the first run around the unit circle here. So I got one shot at this. You don't have to think about the plus 2 pi stuff and all the solutions, just in the first time around, what solves this equation. Now, when you see you have an addition or subtraction here, you're thinking, I wonder if I could get this to be multiplication somehow, because if it equals 0, I can use the zero product property to help me find the zeros. The way we do that is we factor. So look for a GCF first. They have sine of x in common, so I'm going to factor out the sine of an x, and I'm left with the cosine of x minus 1. So what I was saying before is, if I have two numbers and I multiply them together and get 0, one of them has to be 0. It's called the zero product property. So either this is 0 or the cosine of x minus 1 is 0. So I'm going to write two little mini equations and say either that's 0 or the cosine of x minus 1 is 0. And then I can solve those little mini equations. I'll get the cosine of x equals 1 here, and we'll see if we can think of when these things happen. When is sine 0? Sines are y values, so when is the y value 0? That's right here, and that's right here. So that would be at 0 and at pi. And when is cosine 1? Cosine is 1, that's your x value up here at the top, so that would be at pi over 2. So, no, that's wrong. I'm sorry, I don't know what I'm thinking. That's when sine is 1. Cosine is 1, over here is 0. I've already got that one listed. So, the times that this happens, that's kind of a double count. This happens at 0, and this happens at pi. Okay? So cosine of x is 1 right there, because this is order pair is 1, 0, but we're talking radians, not order pairs. So 0 and pi. You don't have to say plus pi n or anything, because it's just the interval between 0 and 2 pi. Number 6. Alright, this one's a little tricky because you have a sine, this is a quadratic term, and this is a linear term. So sometimes it helps people to do substitution here to help you factor. So this, I'm going to call this u squared, and I'm going to call that u. And I'm going to treat this like any other quadratic I've been solving since Algebra 1. So I'm going to split the middle. 2 times 2 is 4, so I need numbers that multiply to 4 and add to the middle, which is negative 5. Those numbers are negative 4 and negative 1. And now what I need to do is factor. It's 4 terms by grouping, so find the GCF. And if you do it right, they should have something in common. So one of your factors is u minus 2, the other is 2u minus 1. Which means u either equals 2, or if you isolate u in that little mini equation, you would get u equals 1/2, because 2 times 1/2 minus 1 is 0. Now we got to go back and say, wait a minute, I don't care what u is, I want to know what sine of x is. So this is a substitution, and I need to know when the sine of x is 2, or I need to know when the sine of x is 1/2. So I'm like, when is sine 2? On the unit circle, when is sine 2? Wait a minute, it's a 1 unit circle. That never happens. Sine is never 2 on the unit circle. But sine is 1/2. Sine is positive in the first quadrant with a 30-degree reference angle, and in the second quadrant with a 30-degree reference angle, which in radians, since we live in radians, would be at, this is 1 pi over 6, and this is 5 pi over 6. So when does this happen? At pi over 6 and 5 pi over 6. Again, you don't need to think about it going all the way around like the multiple iterations, because we have a restricted interval here between 0 and 2 pi. Let's do one where it says find all solutions. So to find all solutions, we're going to have to deal with the plus 2 pi n and stuff. Oh goodness. This one has a sine squared and a cosine squared, and you got to be thinking, oh, that doesn't look good. Well, it would be great if I could make these the same trig function, and what's cool is when you have a sine squared, you're always able to do a little bit of a conversion here to the other one. If I want to do a substitution here, I can isolate sine squared and say that's 1 minus cosine squared. So what I'm going to do is I'm going to say this is 1 minus cosine squared x, and we'll see if that helps us. If I can just live with cosine squared, that'd be a lot better. So when I distribute, I get 4 minus 4 cosine squared x plus 2 cosine squared x equals 3. And I'll combine some like terms. These are both cosine squareds, so if you have negative 4 and you add 2, that's negative 2 cosine squared x's. I still have that 4 out front. If I subtract 4 on both sides, I have negative 2 cosine squared equals 3 minus 4 is negative 1. And now I can get cosine squared by itself, so cosine squared x equals 1 over 2. We're getting warmer, but I don't care what cosine squared is. I want cosine, so I'm going to square root, and this is huge. When you square root both sides, you have to remember that there's two potential answers here. So remember your plus and minus. The cosine of x is plus or minus 1 over, because the square root of 1 is 1, the square root of 2 is the square root of 2. That's hideous, so we're going to rationalize it. We'll give them a buddy, radical 2, and now what I'm ultimately trying to find is when is the cosine of x equal to plus or minus radical 2 over 2. So when does that happen? When is cosine radical 2 over 2? Well, that happens when you have a 45-degree reference angle. That would be a positive radical 2 over 2, or a 45-degree reference angle here when it's negative radical 2 over 2. So here we have positives, and here we have negative radical 2s over 2. So I got them all there. So this in radians is pi over 4. This is 3 pi over 4, 4 pi over 4, 5 pi over 4, 6, 7 pi over 4. Okay? I think we can make this pretty fancy here. You could do pi over 4 plus pi n, plus pi n, plus pi n, and 3 pi over 4 plus pi n, plus pi n, plus pi n. But since these are evenly spaced, these are all 90 degrees apart, you can actually condense this into one statement. So what I'm going to do is I'm going to start at pi over 4, x equals pi over 4, and I'm going to add 90 degrees, so pi over 2n, and I'm going to condense that whole thing into one big statement, which is kind of cool when that happens, but it doesn't always happen that way. Usually you'll have 2, 3, sometimes you could even have 4 answers here for these sorts of problems. Alright, number 8, you have 1, 2, 3, 4 terms, and you see that you have a pretty higher degree polynomial. This is a cubic. So when you have 4 terms, you're thinking, that's not good. Let's see if we can factor this thing to bring it down a degree or 2. When you factor with 4 terms, you're going to factor by grouping. So we're going to find the GCF of those 2 terms, which would be 3 tangent squared x, and you'll be left with a tangent of x minus 1. When you factor the right side, that kind of bothers me, that's a different color, there you go, minus, the GCF over here is really just a 1, and then you're left with tangent of x, and this is important, when you factor out the negative, that's a minus 1, again, that bothers me, so equals 0. That's cool because you'll notice that those are the same, so one of my factors is the tangent of x minus 1, and the other factor is 3 tangent squared of x minus 1. 3 tangent squared x minus 1. That's where that comes from. And the whole point of this is that, again, we're factoring, we're going to use the zero product property to our advantage. So I'm going to take this factor and say, if u equals 0, I'm good. If u equals 0, I'm good. So I have to solve these little mini equations now. So when does the tangent of x equal 1? Or when does tangent squared x equal add 1 divided by 3, 1/3? Which, I have to keep going with that. Square root, oh my gosh, plus or minus 1 over radical 3, which, when you rationalize it, actually makes it a little better. Tangent of x is radical 3 over 3. Plus or minus. Again, don't forget that because you're going to lose half your answers. So we need to think, when is tangent 1 and when is tangent radical 3 over 3? Tangent is 1 when you have a 45-degree reference angle and you're in the first or third quadrant. Tangent's positive here and here. So 45-degree reference angles are pi over 4 and 5 pi over 4. So that's right here. This is pi over 4 and 5 pi over 4. Or plus or minus radical 3 over 3. So again, you should just know that the tangent of 30 degrees, or pi over 6, is radical 3 over 3. That's not straight. Let's try this. 30-degree reference angle there, or 30-degree reference angles there. So I'm going to try and write these all. This is pi over 6, b is 6. This is 5 pi over 6, this is 7 pi over 6, and this is 11 pi over 6. So we got a lot of answers in this problem, which kind of makes sense because it's a higher degree polynomial. So let's see if we can write all of our answers now. We've got x equals, those are pi apart, so pi over 4 plus pi n. That addresses those two, because pi n is 180 degrees. These are 180 degrees apart, or pi radians apart. I've got those done. I'm going to do the same thing with pi over 6 plus pi n. That addresses those two, but I still need the last two, so 5 pi over 6 plus pi n. So you got a lot of different answers there, but again, it's a cubic. That's probably pretty likely. Home stretch, last two. This one you can kind of do pretty quick in your head. You're trying to get tangent by itself, so the tangent of x is negative 1 over radical 3, which when you rationalize that, this is very similar to the problem we just did. This would be negative radical 3 over 3. So when does tangent have a value of negative radical 3 over 3? Those are 30-degree reference angles, but you're dealing with a negative tangent, so tangent is negative in the second and fourth quadrant, so these are 30-degree reference angles. This happens at 11 pi over 6 and at 5 pi over 6. So for those two, I can isolate that into one statement, 5 pi over 6 plus pi n, and there you go. Last one, we're going to get cosine by itself, so I'm going to subtract 1 and divide by 2. That's negative 1/2. And we're trying to figure out when cosine is negative. Cosine is negative in the second and third quadrants over here. So cosine is the short side when you have a 60-degree reference angle. So these are 60-degree reference angles, or in radians, that's 2 pi over 3. This is 4 pi over 3. So those aren't 180 apart from each other, so you can't condense this. You're just going to say 2 pi over 3 plus 2 pi n. If you go all the way around again, you're good. Or 4 pi over 3 plus 2 pi n. So that's it for the study guide. If you can do the study guide and you did your crash course, you guys are going to crush this test tomorrow. So good luck.